Next thing we're going to look at is propane. This is one of the tricks I do. If I run propane to an engine, add propane to it, and the RPM drops, it was probably running already rich anyway. If I run propane to the engine and the RPM kicks up, the engine was running lean. I got a vacuum leak, something affecting it. If I run propane slowly to the engine, the RPM drops and it starts compensating, bringing it back up. It probably was running okay before I started. So it's another way to check fuel control. But if you got an EGR, you run propane to the engine, the RPM is going to drop because it thinks that you've adding, it makes it go richer. EGR in the cylinder thinks it's richer, so you got a problem. If I have a lean condition, whenever I run propane to it, the RPM should kick up slightly, depending on the speed density and mass airflow sensor car. I also use a valve on this. So what I use is a little metering valve or a flow valve on here so I can see how much propane I'm adding. If I'm adding a lot of propane to the engine, and before it changes, I'm not going to worry about it. If I add just a slight bit of propane, really affects the engine, I know I have a problem. Next thing we're going to look at is compression gauge usage. Most technicians don't like using compression gauges. They don't like doing compression tests because the engine has to be warm when you're doing this. In some cars, a V10 Fords, that'd be almost impossible to do. But a good idea is do a cranking compression test. You want to disable the fuel or ignition or both on the particular car. The throttle plate's got to be open. The first pulse or the first hit on the gauge must be 50% of the final. If it's not 50% of the final, you might have a ring problem or you might have a taper cylinder wall problem on it. The second pulse should be about 90% of the final reading, and there's 4 pulses total. When you come up, you want to get the compression reading. Now, that's great. The only problem about it is that's telling you if the system is sealing at idle. It doesn't take in effect the dynamic compression or the cylinder contribution when your engine is running. So the next thing we're going to do is do an engine running compression test. So leave that, if that's a cylinder you got a problem with, leave the compression gauge in there. Run the engine at idle with the gauge on the cylinders misfiring. And what you might want to do, you want to see 50 to 70% of the cranking pressure. Now, if you rev the engine up, it will drop down. If you look at the thing, you want to do a snap throttle test on this. Now, a lot of guys leave the Schrader valve in, and some of them take the Schrader valve out. That's up to you. I leave mine in and burp the gauge on a regular basis. Now, if I snap the throttle, when I go wide open throttle, I should be 80% of my cranking compression. If I'm not approximately 80% of my cranking compression, I have a problem with this particular car. To make this a little bit easier to understand, what I've done is come up with a running compression. If the engine's at 18 inches of vacuum, let's say we're down here, right now we're in Florida, and it's 30 inches of barrel. If at 30 minus 18, that's 12 inches difference. Well, if I divide 12 inches by 2 to get my pressure, it should be 6 psi. So if I take my compression ratio, this is a weak odor engine, it's 8-to-1 compression. Find out what yours is. And 8 times 6 equals 48 psi. So at idle, I should be about 50 psi at idle. The throttle using the throttle plate, not the accelerator pedal. Now, when you snap the throttle, if everything's working properly, if I had a static compression of 150, I have an idle compression of 75, a snap throttle of 125, then I'm looking at a good running engine, 125, 130. We're only going to be looking at the problem with cylinder number 1. Now, if I snap the throttle and the pressure doesn't rise much above my running idle compression, that means I have a restricted intake. One of the guys I worked with one time left a rag in the intake and put the engine back together. And we found it this way. So if I do this, that means on the intake side, something's affecting my flow on this engine. Could that be an intake manifold? Could that be a vacuum leak? I don't know. You guys have to figure out where the problem is, but something's affecting the feed in that particular cylinder. Now, on this one, I've got 180 pounds of compression. If I can't get it out, then my restriction's on my exhaust. Now, let's go back to this one. One thing, restricted intake. Could that be a worn valve guide? Could that be a push rod? Anything affecting the intake into the air in the system. Now, at this point, I'm on the exhaust side. Could that be a restricted exhaust system? Don't think so, because of what, guys? All the rest of the cylinders are okay. Could that be a cam problem on the exhaust side? Could that be an exhaust manifold problem up there where it's restricted somewhere? Rare, but I've seen it happen a couple of times. I had some racing Jeeps where somebody forgot to cut out the runner inside the intake, the exhaust manifold, caused a problem. So I have a restricted exhaust system. That cylinder with a restricted exhaust system will be filled with exhaust gases and not with the proper air-fuel mixture. So I will have a miss on this system and maybe a popping back through the intake manifold. So that's one thing you might be looking at with using a compression test.